um, sign. Okay, so the important things that we need to import are from crypto.signature import pk cs1. I guess that's one. Okay, and then from crypto hash 256. We will be using this SHA-256 to hash our messages, and we also need one crypto.public key import RSA. So first of all, what we'll do is we will create a key pair, and let's say key equals RSA.generate, and let's say the size of this we want as 1024. So this library supports the size from 512 to 2056. So, but we'll be going for 1024. So this key is an object that contains the private key and the public key. So first of all, let's extract the private key. Key.export key. Oops. And the public key is key.public key export key. And let's see what have we got. Okay, so it seems that it does not like the syntax. I think I forgot to put the parenthesis in this one. So let's try again. Hope this should work. Okay, so now we have got the RSA key pair, that's private key and the public key. So now let's store this private and public key into some place. Well, usually we store them in a file, but right now I'm just going to store them in these local variables. Okay, so we have got the public key and the private key. Now let's get rid of this, and now let's get started with signing the signature by the private key, and we will do that as so first of all, let's create a message. Hello world, and we need to hash this message as 256 new message. So we are going to hash the message, and oops, I think I need to remove this. Yeah. And once the hash is done, now we have to create a sign object through which we can sign the message. So we will say signer equals pk c.new, and we have to give here our private key. So we have the private key in our local variable, but we can't directly give that key into this because we need to create a variable for that. So how we will do that is, let's say private key equals RSA dot import key. I guess this one is fine. Now here it should come private key and public key equals RSA dot import key public key. So now we have got our objects of private and public key, and we are going to pass this private key into this signer object. And now we need to create a signature because we have got our hash function and we have got our private key. Now let's create a signature. Signatures equals signer dot sign h. Now this signature is being signed by this hash value and the private key that we passed to this signer. Now the message has been signed, and now let's try to print the signature and see what is it. So it's giving me some random kind of ASCII characters, but so we will gonna make something more in a readable form so that we can give that signature to the JavaScript code as well. And for that, we will gonna convert this signature into hexadecimal form. So how we'll do that is, first of all, we are going to import codex. And we are going to convert this into hexadecimal form. So we'll say hexify equals codex dot get coder hex, and we can store this in a variable m. Hexify signature. So this is gonna return me a list, so we need to fetch the first item of the list. And let's try to print this now. It should give me in a hexadecimal form. Oops, non-hexadecimal digit found. So what can be the issue? Okay, so actually I don't need to decode it, I actually need to encode it. Get encoder instead of decoding. So okay, so now we have got this hexadecimal form signature. Now I guess the Python part is done. Now what we're gonna do is we're gonna take the JavaScript library and copy the same keys into that library and give it the same signature, and let's try to verify the message. So and for that I'm using a JavaScript library called JS RSA sign. It's a pretty much good library. It contains almost all kind of algorithms that you need, and it has a very good sample console over which you can go and you can try to sign and verify your own messages by providing your own public and private keys. So the good thing about that is like we don't have to code in JavaScript, so we'll just simply gonna test it over here. And at the back end the code is very simple. You can simply copy and paste the code and you can use it. So yeah, so here we can see the private key and the public key, and actually for verifying we only need the public key, and so let's copy the public key. Oh, actually this is the one. Let's paste the public key over here, and my signature is this one. Okay, and my message was hello world. Make sure you copy exactly the same message. Okay, so suppose that the Python has created a message and it has created a signature of that message by using the hash function, and it has sent this message along with the signature to the JavaScript library, and the JavaScript library receives this signature and receives this message, and it also knows the Python's public key as well. I mean to say the server's public key. So now if I'm going to verify this, it should say successfully verified. Okay, so we have a problem. So it says the signature is not valid. Why is that so? Alright guys, so seems like I found the issue. The issue was actually when I was trying to copy this signature from Python to JavaScript, I got some blank spaces and the next line, so I need to make sure that I remove all of these blank spaces. So forget about this private part, because this part, everything that is happening over here, we are doing in Python right now. So we are only concerned with this part, the verification part. So we have pasted our signature and the message is hello world, and we know the server's public key. Now if you verify, so it says the signature is valid. That's good. So that means that the message was real and we got it from the real sender. So for example, now let's say we change the message by simply adding a small dot. And now if you verify, it will gonna say signature is not valid. And that is because when the JavaScript code tried to create a hash function of this message, so the hash function did not match, because the message has changed by simply putting a single dot. On the other hand, if we keep the message same and if we change one single byte in the signature from 5 to U, and then again the signature will not be valid. And if I change it back to 5, you will gonna validate the signature. So that's how it will gonna work. And at the back end of this page, the code is very simple. It's of 2 or 3 lines code. Let me show you guys. So here is the code for signing, but this part we are doing in Python. And this is the function for verifying. And it simply takes the message and it takes the hash function. And the hash function we are creating over here, I mean, you can do it separately over here as well if you don't have this part. And yes, so you are creating an object of public key, and then